There are many applications of physics in softball, and in this video, we will specifically be exploring the role that kinetic energy, projectile motion, and the impulse-momentum theorem play in the sport. A moving softball possesses kinetic energy, the energy of motion. Kinetic energy is equal to work times displacement. This means that the greater the distance the ball travels, and the greater the force applied to the ball before being released, the greater kinetic energy the ball will have. This explains many of the mechanics behind a softball pitcher's windup. The windmill motion of a softball pitcher's arm increases the displacement of the ball. The pitcher also increases the force of her release through a series of forward motions over the course of her windup. The pitcher rocks backward and then pushes forward off the mound to generate more force. Her wrist snap at the end of the pitch also contributes to the amount of force applied to the ball and helps increase the kinetic energy of the ball. When a softball is pitched, the ball is known as a projectile, an object that is thrown such that it has no means of self-propulsion. Gravity is acting on the ball as it travels from the pitcher's hand toward home plate. The mass of an average 12-inch softball is 0.188 kilograms. So, using the formula for the force of gravity equals mass times gravitational acceleration, 9.81, the force acting on the ball is equal to 1.84 newtons. Projectiles follow curved paths called trajectories, which are shaped like parabolic curves. To find the projectile motion of the ball after it has been released, you must break apart the parts of the projectile motion into their x and y components using these uniformly accelerated motion equations. In these UAMs, the two equations are linked by the common variable, time. The impulse-momentum theorem plays a crucial role in hitting a softball. To change an object's momentum, a force must be applied to the object over a period of time. The softball has momentum heading toward home plate after it has been released by the pitcher. In order to drastically change the momentum of the ball to go the opposite direction, the batter must swing their bat with a great force and apply this force to the ball for as long as possible. This idea is modeled by the equation momentum, P, equals the change in force multiplied by the amount of time the force is applied for. The greater the force applied to the ball and the longer the time, the greater the change in momentum, thus causing the ball to travel farther. These are only a few of the many ways physics impacts softball, let alone our everyday lives. Physics is in action all around us, controlling and shaping the world in which we live.